Down the line, introductions.
I'm Lucas.
I'm Aydan.
And I'm Paul.
And this is the Galileo ball dropping, ball pushing experiment.
Something like that.
Yeah. Cool.
Hey everyone, this is Lucas doing the introduction to the experiment here, giving you a little bit of background. So today we will be demonstrating a very complicated experiment, an abstract experiment, and we're doing a little bit of variation on Galileo's original experiment with the falling ball. So today we're going to add some horizontal velocity off of a table to it and see if that adds any extra velocity to the rate of falling for the ball. So back in 300 BCE, Aristotle didn't believe in doing experiments. He believed logic was enough, and he said a larger object would fall faster than a smaller object. And no one tested out this theory until 1590. Galileo decided to test this theory out. He concluded that if you drop two differently weighed objects, they should land at around the same time, considering air resistance and other factors at the time. A similar experiment took place some years earlier in Delft in the Netherlands when the mathematician and physicist Simon Stevin and Jan Cornets de Groot conducted the experiment at the top of the Nieuwenkerk. The experiment described in Simon Steven's book, not pronouncing the title, subtitle. Also, astronaut David Scott performed a version of the experiment on the moon during the Apollo 15 mission in 1971, dropping a feather and a hammer from his hands. Because of the negligible lunar atmosphere, there was no drag on the feather, which hit the ground at the same time as the hammer.
Oh, hey there.
Hi.
My name is Paul Anderson. And we're going to be going over Galileo's experiment today. So I'm going to be dropping a ball from about this table height and trying to calculate the time it takes to get down on my phone stopwatch. Then we're going to roll it off the table, and when it leaves the table, I'm going to do the same thing with the stopwatch, and hopefully they'll be close, if not the same. So let me get my stopwatch ready.
You suck.
Alrighty, so we're going to start off by dropping the ball. 3, 2, 1. Alrighty. So I got 0.33 seconds on the phone. I know this isn't the most functional way to do it, but we're just testing it out for the first time. Now we're going to roll it off and see what we get. Messed up. 3, 2, 1. I got 0.21 seconds. Restart, and then roll it off the table and try it that way. 3, 2, 1. I got 0.23 seconds. So as you can see, it's about the same time. The only difference was one ball traveled further than the other one. Now we're gonna do both balls at the same time, so you can kind of see.
Would you like some assistance there, my friend?
So you can kind of see them both. He's gonna roll it off. I'm gonna drop at the same time, and we're gonna see if they hit the ground at the same time on you.
All right, 3, 2, 1.
We're gonna do it one more time. As you can see, it kind of worked the same. Roll a little bit faster.
All right, here we go. 3, 2, 1.
That one was better. You can see they almost hit the ground at the same time, but one ball hit over here, the other ball hit here.
Do it one more time for the folks at home. One more time. Here we go. 3, 2, 1.
One more time.
One more time.
One more time. 3, 2, 1.
I'm dropping it way.
3, 2, 1.
There we go.
There. All right. So as you can see clearly in the video,
Both balls hit the ground at the same time.
Hey guys, it's Aydan. So to analyze the experiment that just took place, we recognize that both balls will accelerate downwards at exactly the same rate. However, the horizontally thrown ball will have a starting velocity horizontal to the building velocity. The sum of the two vectors will always be higher than that of a single vector alone. Consider a right triangle. The vector down is like one of the right sides, and the vector sideways is like the right side. the hypotenuse is the total speed of the ball. The hypotenuse will always be longer than the either side. The total speed of the thrown ball will always be higher than the one that is just dropped. Got it? Good. Just so we all know that the gravitational pull on this Earth is 9.8 meters per second squared. And with the theories of Galileo's going at, back to his leaning of Tower of Pisa experiment, it should be no matter what weight each ball is, they should fall and hit the ground at the same time. This is exactly what the experiment the astronauts on the moon did, and we're just going to replicate it right here. So I have the soccer ball and the paper ball, and according to Galileo, they should hit the ground at the same time. So I'm just going to level them off, and then count of 3, drop them. Ready? 1, 2, 3. Looked like they hit the ground at the same time, so that is a good thing. Well, that was it. So hope you guys learned something new and important.
At least something.
Yes.
One thing,
One
hopefully.
thing. Thank you for watching.
Thank you.
See you never.